Welcome students to another lecture on engineering graphics. Today we will cover second problem on orthographic projections. So let us start the lecture. So we are given one problem and we are asked to draw its front view and top view in first angle of projection. So in order to draw its front view and top view in first angle of projection, we have to first see that is its front view marked in the diagram given to us. So if you will see this picture, in this picture, one arrowhead is given to us. So that arrowhead is pointing towards the front side of this particular object. It means we have to read this object from this direction only, and we have to assume that observer is standing this side, and this is the front side of the object. As we have to solve this problem in first angle of projection, that means we are assuming that object is in the first quadrant. And if observer is standing over here, then in the first quadrant VP will lie behind the object and HP will lie below the object. So after that we will see the dimensions of this object. So if we are reading this object from front side, it means the dimensions which are moving left to right of the observer are called as length dimensions, and the dimensions which are moving away from the observer are width dimensions, and the dimensions which are moving in upward direction are height dimensions for the observer. Okay, so after this we have to start with the front view, and we know that when observer looks at the object from front, then he can see only those faces which are either parallel to VP and inclined to VP, and we know in this case VP is lying behind the object. So for that, what we have to do, first of all we have to see how many total number of faces are there in this object. So let us label all the faces in order to understand the total number of faces present in the object. So we have 1, 2, 3, that is opposite to 2, then face 4, 5, 6, 7, 8, 9, 10, opposite to 10 is 11, 12, 13 and 14. So we have around 14 faces in this particular picture. So now we have to identify how many faces are parallel to VP. So you can see there are 3 faces parallel to VP, face number 1, face number 7, face number 8. And now let us see how many are inclined to VP. So there are 3 faces inclined to VP, face number 2, face number 3 and face number 9. So it means we are left with 6 faces which are either parallel to the vertical plane or inclined to the vertical plane. Or we can say these 6 faces will be visible to the observer from front side. So it means if we have to draw the front view of this object, we have to draw these 6 faces in the front view with their proper dimension and location with respect to each other. Now over here in this problem we have included inclined faces also. In the very first problem there were only 2 kinds of faces, parallel faces and perpendicular faces. But in this problem we have included one more category, that is inclined faces. So if you are solving a problem in which you have parallel faces and inclined faces, then you have to understand one point over here. We have concluded that we have to plot 6 faces in order to draw the front view of this object. So out of those 6 faces, 3 are parallel faces and 3 are inclined faces. So if you will get such situation where you have both parallel and inclined faces in the object, then you have to first plot the parallel faces. After that you should plot the inclined faces. If you will follow this sequence, then it will be easy for you to plot the inclined faces. Okay, now let us first start with the parallel faces. So let us see how many faces are there which are parallel to VP. So out of these 6 faces, there are 3 parallel faces. Face number 1, face number 7 and face number 8. Now we have to decide with which face we should start. We can start with any face, but what we should do, we should pick that face first which is close to HP. So it will be easy for you to draw the view then. Okay, we know that we are drawing in the first quadrant, that means HP is below the object. So out of 7, 8 and first face, face 1 is close to HP. So let us pick this face first. So how to plot this face? Let us see how many points are there on this face. There are 4 points. So out of these 4 points, pick the lower left corner and mark that on your paper. So now from this point we will draw the drawing of face 1. So right now we are here. If we have to move to the next point, we have to cover a distance of 16 millimeters. That is a horizontal distance towards right for observer. So from this point we will sketch a line of 16 millimeters towards right, and it will be a continuous thick line, of course, because we are drawing front view of the object. So now we reached at this point. We have to move in upward direction by 8 millimeters. So we have to draw a vertical line of 8 millimeters. Then we have to come back by same distance, that is 16 millimeters, and then we will join these 2 points, and that length will be of 8 millimeters again. So now you can see we are ready with the drawing of face 1. So after that we will plot next parallel face. So after face 1 we have 2 parallel faces, face number 7 and face number 8. You can pick any face first. Let us pick face number 7 first. So in order to plot face number 7, first of all we have to see what is the location of face 7 with respect to face 1. So in order to get its location, let us see how many points are there on that face. On face 7 there are 4 points. So pick any one point and locate that point in face 1. So let us pick this point. Now you can see I have to locate this point with respect to face 1. So move towards face 1. So move along this edge. You will reach up to this point. Now where is this point? This point lies on face 1 at a distance of 4 millimeters from this point. Let us understand why this is 4. See, the total length is 16 and midway length for this face is given to us as 8. So 16 minus 8 divided by 2. So each length on both sides of this face is of 4 millimeters. It means this point is lying on face 1 at a distance of 4 millimeters from this point. So from this point we will mark a point at 4 millimeters, and from that point we will draw this particular height of face 7. And let us see how much is this height now. Total height mentioned to us for the object as 48 millimeters, and this height is mentioned over here as 8 millimeters. It means height for face 7 will be 48 minus 8, that is 40 millimeters. It means from this point, first of all, we will move on this face 1 by 4 millimeters towards right. Then from that point, we will sketch a continuous thick line of 40 millimeters. So we reached at this point. Now how much is the length of face 7? Let us find. Now see, total length of the object is given to us as 40 millimeters. And if we subtract 8 millimeters from that, then we will get 32 millimeters, and we have to divide that by 2 because same lengths are on both sides of this 8 millimeters. It means this is of 16 millimeters. So from this end we will sketch a continuous thick line of 16 millimeters towards right. So we have reached to this point. Now in order to draw this length, we have to draw a vertical line of 40 millimeters again. So now we will connect these 2 points, and that length will be equal to 16 millimeters again. So now you can see we are ready with the drawing of face 7 as well. Now we will plot the next parallel face, that is face number 8. Now if you will observe carefully, you will find face number 8 is exactly similar to face 7. So we will follow same steps to draw face number 8. So before drawing that face, let me clear one point over here. When we draw orthographic projections from isometric projections given to us, these are called as isometric projections, it may happen that some part of the object may not be visible in that picture. So this is the limitation of such views. But you have to see carefully and you have to judge carefully that whether the object is a symmetrical object. You can see clearly that this is symmetric about this particular center line. So whatever we have on the left side, same we will consider on the right side. So don't get confused. If you feel that this portion is not visible, then see the overall symmetry of the object. And from the symmetry, you will find that face number 8 is exactly similar to face number 7. So let us plot face number 7 now. So for that, we will follow same method. That is, from this end, we will move 4 millimeters towards left and will mark a point. From that point, we will sketch a vertical line of 40 millimeters. And we will reach to this point, and from that point move towards right by 16, then come back again down by 40 millimeters, and then we will join these 2 points, and that length will be how much? Total 16 millimeters. So now you can see we are ready with face 8 also. Now we will plot the inclined faces. So how many inclined faces are there? We have 3 inclined faces, face number 2, face number 3 and face number 9. So let us start with face number 2. In the very first lecture of orthographic projections, we have learned that if we have inclined faces, then when you look at those faces from front, you cannot see their length. Fine? Means true length will not be visible. From front, you will see their reduced length. So if you will look at this face 2 from front, you can see one ray of sight will strike at this point, second ray of sight will strike at that point. So distance between those two rays of sight will be visible from front. So that distance over here is 12 millimeters. It means if I have to plot this inclined face in the front view, I have to show this as a reduced shape, means a rectangle of reduced length, because this inclined length will not be visible from front. For this face, only this portion of that length will be visible, that is 12 millimeters. It means for face number 2, we have to draw a rectangle whose length will be 12 millimeters and whose height will be complete height, that is 8 millimeters given in this question. Okay, so how to plot face number 2? Rules are again same. See how many points are there on that face. How many? 1, 2, 3, 4. So pick any one point and plot that point or locate that point with respect to other faces drawn by us. Now if we will pick this point of face 2, you can see this point of face 2 is also shared by face 1, and that point is already marked over here. It means we have located the position of face 2 with respect to face 1. Now from this point I can start the drawing of face 2, and we have concluded that from front we will see the length of face 2 as 12 millimeters only. So from this point draw a thick line of 12 millimeters, and we will reach from this point to that point, and from that point we will draw a line of 8 millimeters in our direction. So you can see we are done with face number 2 as well. So let us plot the next inclined face, face number 9. So how to plot face number 9? Rules are again same. See how many points are there on face number 9. There are 4 points. 1, 2, 3, 4. Now you can see these 2 points of face 9 are already plotted here. So you can see the benefit of drawing parallel faces first. If you will draw parallel faces first, then it will be easy for you to draw inclined faces. Now for face number 9, these 2 points were on face 1, and these 2 are already located over here because of the drawing of face 7 and face 8. It means now we have to locate these 2 points only. So let us see where we have to locate these points. Now face number 9 is inclined face, inclined to vertical plane. So when you will look from front, you cannot see this length or this height. You will see this height for face 9, and this height is how much? It is 12 mm from top. So these 2 points are at 12 mm from top, or I can say this point of face 9 is exactly below this point, and this point is over here. It means from that point how much I should move in downward direction? 12 millimeters. So from this point I will move by 12 millimeters and I will draw a continuous thick horizontal line. Now you can see face number 9 is also plotted. Now after that we will plot face number 3, and face number 3 is exactly similar to face number 2. It means for that what we will do, from this end we will draw a thick line of 12 millimeters on the other side, and we will connect these 2 points to get the height of that face, that is face number 3. Now you can see we are ready with the front view of this particular object. Now what is the next step? Next step is we should draw a reference line below the front view by leaving 1 row gap or 2 row gap. That means 10 millimeters or 20 millimeters. It's up to you depending upon the space you have on your grid sheet, but minimum gap should be of 10 millimeters. Why we are drawing in this XY line below front view? Because we are drawing in first angle of projection. So we have to keep the front view above reference line. So let us mark this reference line as capital X, capital Y. And what is the next step? Next step is from all the points of front view, we will take continuous thick lines in downward direction. Means we will draw projectors in downward direction. These projectors are continuous thin, parallel to each other and are perpendicular to plane of projection. So you can see 3 points are there on this line, but from these 3 points we will get only one projector. Same is the case for all other points over here. Now after drawing these projectors, we will work for its top view. So it means if we have to draw its top view, we have to change our position and we have to look at this object from top. But we have to maintain the same direction. We will not change the direction. We will continue to look at the object from this direction, but now we will see it from top. So direction is maintained, but we are looking at the object from top. So what is the rule? So next rule is again same. That means if you want to draw its top view, first of all, see how many total number of faces are there. Again, same number of faces will be there. Earlier we concluded that in this picture there are 14 faces. So we have labeled those faces again. Now out of these 14 faces, we will see only those faces which are either parallel to horizontal plane or inclined to horizontal plane. So let us see how many are parallel to horizontal plane. First of all, we should know where is horizontal plane. Horizontal plane is lying below the object and we are looking from top. So when you look from top, let us see how many parallel faces we will see. Face number 12, 14, 13, 5, 6. So we have 5 faces parallel to HP. And let us see how many faces will be inclined to HP. Only face number 9 will be inclined to HP. It means what we have concluded that we have to plot these 6 faces. Face number 12, 14, 13, 5, 9 and 6 in their proper dimension and location in order to get its top view. And we know that if we have both the faces, parallel and inclined faces, we will start with parallel faces first. So let us start with parallel faces first. So how many faces are parallel to HP? There are 4 faces, 12, 14, 13, 5, 6. Now out of these 4 parallel faces, we will pick that face first which is close to VP. In case of front view, we said pick that face first which is close to HP because we were drawing above reference line. But now we have to draw below reference line, that means from VP. So we have to pick that face which is close to VP or close to reference line. So you can see face number 12, 14 and 13. These 3 faces are at same distance from VP. So you can pick any face out of these 3. So let us pick the extreme left face, that is face number 12. Now what is the next step? Next step is we have to locate this face in the top view. Or we can say we have to locate this face with respect to front view so that we should select the correct projector for the starting point of this face. So let us see how many total points are there for this face. There are 4 points, 1, 2, 3, 4. And out of these 4 points, we'll pick that point which is close to VP. So out of these 4 points, there are 2 points close to VP. So out of these 2, we can pick any one. Let us pick this point. So we have picked this point of face 12. Now we'll see the location of this point in the front view so that we should select correct projector. So let us move towards front view from this point. Where is front? Front is this side. So from this point move towards front. Follow this edge. You will reach up to this point. And this point belongs to face 5. Face 7, sorry. And that point is over here in the front. So we will select that projector which is coming from that point. It means this point will lie on this projector. So now we'll leave some gap from XY line and we'll mark a point on that projector. So this point represents this point of face 12. Okay, now from this point we'll start the drawing of face 12. So see, this is the direction and observer is looking from top. So for observer, this is length. So how much is the length of phase 12? We have concluded earlier, it is 40 minus 8 divided by 2. So this is 16. So from this point, we will draw a thick horizontal line parallel to xy of 16 millimeters. So we have reached to this point. Now how many units we will move in downward direction? It will be 8. So from this point, draw a thick line in downward direction, and that will be of 8 millimeters. So we have reached at this point. Now we have to draw this length. This length will be again of 16 millimeters. Now we have to complete phase 12 by drawing this height. So how much, sorry, this is width. So how much is this width now? It is again 8 millimeters. So we are ready with phase 12. After that, we have to pick next parallel phase, and next parallel phase is 14. So let us plot phase number 14 next. So again, rules are same. See how many points are there on 14. 1, 2, 3, and fourth point is not visible, but there are 4 points. So let us pick this point of phase 14 and locate phase 14 with respect to the previous phase plotted by us. You can see this point is exactly below this point of the previous phase. This point is over here. It means I can start the drawing of phase 14 from this point. So from this point, how many units we have to move towards right? It is 8. So from this point, we will sketch a line of 8 millimeters. So we have reached to this point. Now from this point, draw its width. How much will be width in the top? It will be equal to 8. So from this point, sketch 8 millimeters. Then draw the back length of phase 14. So connect these 2 points, and that will be equal to 8 millimeters again. Now let us plot the drawing of phase 13. So again, rules are same. See how many points are there. 1, 2, 3, 4. Pick any one point and locate that point with respect to the previous 2 phases plotted by us. So if we pick this point of phase 13, we will see that this point is exactly above this point of phase 14, and this point is already drawn here. It means from this point I can start the drawing of phase 13. So how much we have to move towards right? It is 16. So from this point we will draw a thick line of 16 millimeters. Then we have to draw the width of phase 13, that is 8 millimeters. So from this point draw 8 millimeters. Then connect these 2 points with a length of 16 millimeters. Now you can see we are ready with the drawing of phase 13 as well. Now let us pick the next parallel phase. Next parallel phase is phase number 5. So how to plot phase number 5? Again, rules are same. See how many points are there on this fifth phase. So there are 5 points. 1, 2, 3, 4, 5. Out of these 5 points, pick any one point and locate that point with respect to previous 3 faces drawn by us. Any of these 3 faces. So if we pick this point is exactly below this point of phase 12, and that point is over here. It means from this point I can start the drawing of phase 5. So from this point, how many units I have to move in downward direction, or how much width I have to cover? It will be equal to 36. So from this point we will draw a thick line of 36 millimeters. Now we have reached up to this point. But over here this length is not given to us. So we will stop here only and we'll pick some other point of that phase. So let us pick this point of phase 5 and locate it with respect to other 3 phases. You can see this point is just below this point of phase 12. And this point in the top view is over here. So from this point I can sketch this width of phase 5. So how much is this width? Let us see. Total width of the object is 48 millimeters. But from that width we have to subtract this width. That is 8. It means this is how much? This is 40 millimeters. It means from this point we will sketch a vertical line of 40 millimeters. So we have reached to this point. Now after that we will move towards left, and we know that this distance is 4. 16 minus 8 divided by 2. So this is 4. So from this point sketch a horizontal line of 4 millimeters towards left. So now we have reached to this point. So now we will connect these 2 points with the straight line. So we will get phase number 5. Now you can see phase number 6 is not clearly visible in this picture. But we know object is symmetric. So face number 6 is exactly similar to face 5. So we'll follow same rules for face number 6. So let us plot 36 millimeters from this end and 40 millimeters from this end, then 4 millimeters towards right, then we'll connect these 2 points with straight line. So this is face 6. We have plotted 5 faces which were parallel. Now we are left with inclined face, which is face number 9. Now you can see the benefit of drawing the parallel faces first. Look over here. In order to plot face number 9, we will see how many points are there. There are 4 points. 1, 2, 3, 4. Out of these 4 points, 2 are already plotted. You can see these 2 points. In fact, this length of face 9 is already plotted here. So in order to complete phase 9, we just have to locate these 2 points, and we know these 2 points are on phase 1, or we can say this point is on phase 5. This point is shared by phase 5, and this point is already plotted by us over here. So it means from this point we will sketch a horizontal line and we'll get phase 9. So when you will look at phase 9 from top, you cannot see this width. You will see this base as its width. So this is what we have drawn over here. This is 40. So we are ready with the top view of this particular object. So I hope the procedure of drawing front and top for this particular problem is clear to you. Now we will plot dimensions. So first of all, let us place its height. So how much height is given to us? 48 millimeters. Then we will place its other height dimensions. So we can place this height as 12 millimeters. Then we can place this height as 8 millimeters. So now we are done with all the height dimensions. Now we will plot the complete length. So how much is the complete length? It is 40 millimeters. So that we can plot here. Now after that we will plot the remaining length dimensions. So remaining length dimensions are 16, and after that 8 millimeters that we can plot at the top. Now after plotting length dimensions, we will plot width dimensions. So total width of the object is 48 millimeters, that will place over here. Then place remaining width dimensions, so that is 8 millimeters and 12 millimeters shown over here. So now you can see we are ready with the drawing of this particular object, and we have drawn its front and top in first angle of projection. So I hope this particular answer is clear to you. Thank you very much.